This tutorial is for educational use only. It is not authorized nor approved for any other use.
Okay, let's get this show started, shall we? But first, let me ask you for a quick favor. Hit that subscribe button and smash the like for more amazing content like this. The first thing that we are going to do is we are going to discuss how is the registry smart contract interacting with the account smart contract. So we need to understand that there's a link between the two as far as the function goes. There is the need for the registry smart contract to inform the blockchain that a new token-bound address, a token-bound account, has been made, has been registered, which means that I have to tell the blockchain XYZ account number has a particular function, okay? Has the function to receive ERC-20, has the function to send ERC-20s, etc. It's no different from any other contract that receives or sends ERC-20 because we are implementing an interface to interact with the ERC-20 token, okay? The only difference is that the permissions inside the smart contract are bound to the owner of the NFT. The magic is that if I send the NFT to someone else, the new owner, the new wallet that is holding that NFT should have the rights to execute the functions on the ERC-6551 account smart contract. So we deploy one account smart contract that has, I'm going to say, the identity on the blockchain. It has all the attributes that the wallet can execute, can perform, as far as the send, the withdraw, and all that. So when we interact with an ERC-6551 account, we are interacting with a smart contract. Every time that we generate a new account per NFT ID, we are, quote, interacting with a smart contract. That's basically how we do it, okay? To summarize, we are doing a quick whiteboard so then you can understand the logic between the two, the registry and the account smart contract. We are deploying the ERC-6551 registry smart contract. We are also deploying the ERC-6551 account smart contract. And once we get those two, then we can start generating the NFT token bound accounts, okay? Alrighty, let's go ahead and let's get this show started. Okay, let's get started, right? So we got a NFT collection smart contract. This will be an ERC-721, right? And when we implement token bound accounts, what we are looking effectively is to bound a wallet to the tokens on the ERC-721, okay? So we are going to effectively implement an ERC-6551 account. Once we implement the ERC-6551 account, I can send requests to obtain information to the ERC-721. Why? Because we are going to be interfacing to the ERC-721 NFT collection smart contract. What information do I need to obtain from the ERC-721? The owner of an NFT. Why? Because if I need to withdraw tokens from my ERC-6551 account, I need to know that I'm the owner and I'm allowed to do that, okay? Awesome. So this is literally what we're doing. We're just adding a wallet to an NFT, which means that I need to be able to interact with the ERC-721, right? So I need to be able to talk and, hey, give me the owner of this NFT ID. Is the owner matching the wallet ID that is connected as attempting to perform the call? Is that wallet matching the message sender when we are talking to the account smart contract? And if it is, then allow it to, okay? In order for me to create this account, I need to bring the registry smart contract, okay? So we are going to implement an ERC-6551 registry. What is that doing? It's generating the token address and pushing that onto the blockchain and registering that account onto the blockchain. Okay, so which means that I need to tell the ERC-6551 what's the contract, the NFT contract that we are going to be working or interacting and building those accounts, which means that this smart contract right here, let me go ahead and delete this, which means that this smart contract needs to have a reference to the registry. So it has to be providing the information, or at least it should provide the attributes to the registry smart contract, so then I can build those token bound accounts. When I initialize this registry smart contract, I am going to be providing the NFT collection, and this will be the ERC-721 contract, okay? So I'm going to be providing that address. every time that I register new accounts, okay, again, this will be, quote, the registration contract. Any time that I need to build a new account, I am going to be making the call to the registry to create that account. So the moment I do that, I am going to be providing the address of the smart contract. I am also going to be providing the NFT ID. So I need to tell the smart contract, I am going to give you the NFT ID. Why we need to give this information? Because when we attach the registry smart contract, when we attach that smart contract to the ERC-6551 account, right? When we attach that, the NFT ID will be one of the attributes. It's going to make that call to the token smart contract, and it's going to, let's say, for example, ask who the owner of NFT 10 is. Okay. If the NFT 10 owner is message sender, what is message sender? It is the wallet, or it is the user, or the trigger to a function. So it's basically making the call. It's actually talking to the contract and executing calls. So I am going to be sending a wallet address. I'm going to be sending an address as my message sender. If the message sender is in fact the owner of the NFT ID, right? So if we have the NFT ID that we are interacting on that wallet account, I am going to let that function finish. And there's another item that I have to populate. Not only the NFT ID, also going to be populating the chain ID. What is the chain ID? The chain ID is the integer, the value of the blockchain that we are interacting. So every blockchain, every mainnet, testnet has a chain ID. So we are going to basically provide that chain ID. And what's going to happen is once we provide those values, and there's two other values that we have to work with, which is the salt ID. And this is not the ingredient that you use in food. This is a value that we provide that will make the identifier unique, that will make an address, an object, an ID, anything. It's going to be unique. It's going to be based on uniqueness. Okay, so this will be the salt ID. Let's focus on three items: smart contract, NFT ID, and chain ID. So every time that I want to create a new token-bound account, I have to send the call to the registry, to create the account, and I have to specify those parameters. Once the account gets generated, every time that we interact using the wallet address, so let's say 1A, B, C, D, whatever is that wallet address, every time that I interact with that wallet address, it's literally going to look for those parameters. Why? Because the moment I provided this information and I register that using the registry, there is a moment when we convert this into bytecode, when we hardcode this, in which we combine this into bytes, into bytecode. So by me providing all this information, when we make the call, I am going to be generating a unique ID that once we execute calls using that new token-bound account, the blockchain is going to be able to interpret the bytecode and reference all those values. It's going to be able to translate that to all the values that I provided. So let me go ahead and do one thing here. I'm going to remove all this. Let me clean my whiteboard, okay? So how do we build that token-bound account? We are going to provide the ERC registry, 6551 registry. We are going to be providing the ERC-6551 account contract. This is not the token account that we are going to generate per NFT ID. When we build this initial application, when we build this ERC-6551, we are going to be deploying two smart contracts that are basically base smart contracts, which we then will use to build the token accounts. It's not like I have to deploy a new contract, a new account contract every time for every single NFT. Absolutely not. What we are going to do, we are initially deploying those two smart contracts. Then I am going to obviously obtain the smart contract address for my base account. It has no information about NFTs whatsoever, okay? Listen carefully. We are deploying that account smart contract. We are going to obtain a contract address. What is this contract going to do for us? This is where we provide the available functions to interact with that quote wallet, okay? So this is where I am going to enable ERC-20 transfers. We are going to be able to hold ERC-20s, etc. What else can we do with this account smart contract? We can also accept custom ERC-20s. You see where I'm going? Why? Because this is the contract that we are mostly going to be working on this tutorial. I am going to be making modifications so the account, the wallet that we generate out of this contract has many functions and can accept many ERC-20 tokens. How am I going to be able to accept many tokens? Well, I have to somehow provide the token address, the ERC-20 token address to the account. If, let's say, I want to store USDT on the NFT, what am I going to do? I need to build a function that talks to the ERC-20 interface, but then specifies the contract address of USDT. So in this case, I am going to call send, I'm going to call this send custom, right? Check this out. I am going to be sending custom ERC-20 tokens. I'm going to create this function called send custom. In the statements, I am going to invoke the ERC-20, which is our interface for ERC-20 tokens. Then from there, I am going to do what? I am going to transfer. I can call now functions inside the ERC-20 interface, right? So we can do transfer, we can do burn, we can do all kinds of things. However, the most important thing here, let me change the color. The most important thing that we need to do here is this ERC-20 interface must be bound to the USDT address. Okay, and this will be the USDT contract or any other token smart contract, even your own custom ERC-20 token, okay? Which means that now I have to build this function to allow all this to also accept, so the wallet can receive, can hold, and can withdraw, can remove those tokens out of the Tokenbound account, right? Which means that I'm going to be building this. To summarize, that ERC-6551 account, it's going to dictate what can you do with that wallet, okay? So we have to work with the account and we have to modify that account smart contract to do custom things. And in my case, what I'm going to do in this tutorial, I'm going to allow it to accept other ERC-20 tokens, not just the native token, okay? When I'm going to be deploying the registry smart contract, this account, this smart contract address that we obtain when we deploy the ERC-6551 account, base account, I'm not going to provide any parameters. It's literally a bare account that we are just going to deploy, run, get the address. Now that that contract is live on the blockchain, on the registry smart contract, I can start building those NFT wallet accounts or Tokenbound accounts. And as I mentioned, NFT, the parameters that I'm going to be providing are going to be the NFT ERC-6551 contract. That's the contract address. I'm going to be providing that, the token ID, the NFT ID, the chain ID, and the ERC-6551 account. Why? Because that's how I'm going to tell on the registry smart contract, hey, I want to generate this new ERC-6551 account based on this smart contract and what features does the contract has for that wallet account. And then once we do this, then we can go ahead and use and take advantage of the functions that we are going to be coding into that 6551 account smart contract, okay? It's like me building a blank account that has all the functions, and then I'm going to start using it to build accounts on top of it, okay? It's very straightforward. You're going to see this, and it's very, very straightforward. One last thing before we go ahead and deploy the smart contracts and we interact with that account, which basically is what I'm going to be focusing on. Go ahead and remove all this. How would the account be generated at all, right? And we mentioned we got the ERC-721 contract address. That's one of the values that we provide. We got the token ID or the NFT ID. We got the chain ID, and we got the ERC-6551 account, the one that we are going to initially deploy. We have all those parameters. The moment I provide those parameters to the registry smart contract, the registry smart contract has an interface, and that is the ERC-6551. That what that is going to do is going to build that wallet account. And it's going to be building that wallet account because it's going to be using the byte code. Okay, it's going to be using basically machine language. It's going to be using code on the blockchain. When you compile a smart contract, before you deploy, it has to be converted into bytecode. Look, it's basically hex in values. It's all hex. What the blockchain is able to read is bytecode, which means that I have to grab all this information and spit it out into an address. I have to build that address. So I have to build that wallet address, and it has to be converted into bytecode before it's sent and stored on the blockchain. Okay? How is the contract address generated? I think I'm going a little bit more in depth, not just building NFT wallets. I want to give you even the low level information. Okay. So the moment that account, that address, which is just like a wallet address, that wallet address gets generated, it's using a opcode. It's using a library that builds those contract addresses. When you deploy a smart contract, right? When you deploy, let's say you deploy an ERC, any smart contract, you write to the blockchain, you deploy a smart contract. There is an address that is generated, right? So there's a smart contract address that gets generated during the deployment. That, ladies and gentlemen, is the blockchain generating that smart contract address, and it's generated using bytecode and is using opcode. There's a module that we use in the 6551 to generate those addresses, and it's the open separating create2. So it's called the create2. You are going to see it. Don't worry, you don't have to actually write this. All you have to do is import it. And there is a function that we are going to go over that actually builds the wallet account, which means that even before the contract gets generated on the blockchain, we are able to obtain what the address is going to be. Why this is very important? You might be wondering, why do I even care if I need to know the wallet that is going to be generated beforehand? Well, ladies and gentlemen, the reason why is because there is a read function. There is a function to view on the registry smart contract that I not necessarily have to deploy in order for me to know the wallet address. I don't need to provide this and deploy in order for me to figure out what the wallet address is going to be. Instead, there is a view function that allows me to calculate and generate the values without actually deploying it. You see where I'm going? Why is that so important? It's because with this, I can effectively build a front end, and just by passing all this information during the rendering of the front end, I can ask the registry smart contract, give me the wallet address, and I can display it. Even if the user hasn't built any NFT account, I still can show the user what the wallet address is going to be, regardless if I deploy it or not. You see how cool this is? Now I do have a function on the registry that allows me to just provide the information, and the registry is going to give me the wallet address for any NFT, okay? So that is very cool, which means that I can use that to do view calls. I am going to be building a front end, and every time someone clicks in NFT ID, I should be able to generate that address on the fly and show it on screen. If the user decides to build the account, he can click create account, and they are going to create the account on the fly, and the wallet's not going to change because we are already pre-calculating the values. The values, I'm going to be providing those values beforehand. Very cool. So let's go ahead. So now that you know how this all works, registry, and we got the account, build the account, and then we use the account to deposit the tokens, interact tokens. Okay, so now with the account, I can interact, I can do everything. And again, if I transfer the NFT to someone else, the smart contract, the registry smart contract, is binded. It's attached to the NFT smart contract address, which we provided when we initially generate the token ID, that wallet ID. Okay, let's go ahead and let's stage and code the smart contract. Let's build the smart contract. Let's build the account smart contract. And let's modify the account smart contract so that we can use custom ERC-20 tokens. Let's deploy. What I'm going to do, I'm going to be deploying the NFT smart contract. I am going to be deploying the token smart contract, a test token, so that we can try and see if we can deposit and withdraw test tokens as well. Okay, so let's go ahead and do that. Okie dokie, so there you have it. This is the ERC-6551 Registry Smart Contract. What we are first going to do, I'm going to give you the information straight out of the EIP. This is the Ethereum Improvement Proposal, right? So we have the ERC-6551, and what we have to work with, I want to show you real quick. If we scroll all the way down, there we go. This will be the interface, okay? So this is what I want to show you. So we are going to work with the ERC-6551 registry. This interface is the one that I was explaining to you that will generate the Tokenbound account, okay? So if I have this function right here, this function to create the account is going to require the following, the implementation. What's the implementation? This will be the base account smart contract. As I mentioned, we are going to be deploying the account smart contract. Then with that as account smart contract, then I can build token bound accounts, okay? With the salt, I can build a deterministic address. It's basically a way for me to generate the uniqueness of the address by providing the information, by providing the salt, okay? So the chain ID, it's going to be the blockchain that we have this smart contract deployed, okay? And we obviously have to provide the token smart contract, and this will be the NFT smart contract, as well as the token ID, okay? Let's go and take a look at the contract itself, okay? So what am I doing? Importing the create2. And as I mentioned at the end of the whiteboard session, the create2 allows the smart contract to pre-compute, to pre-build the address. So we know what's the account address of that's going to be assigned to the actual NFT wallet, or in this case to the ERC-6551 bound. So with the create2, I can compute the address that will be the ERC-6551 token bound account. Let me show you the app, okay? So I want to show you the app. So on the app, if you can see over here, let me see if I can scroll in. There we go. So if you can see right here, this will be the token bound account, okay? So how am I able to click every NFT and create this address on the fly? And the reason why is because with the create2 and the registry, I have a function that allows me to view without deploying the address, or in this case, deploy the token bound account, okay? Which means that I can pre-generate the address and display this, because I can be calling the blockchain and I can be performing that view and obtaining the value, and then I can pass that to the front end, okay? Beautiful. Okay, so let's go ahead and take a look at the registry, okay? Let's break it down with the registry first. Let's take a look first at the function that actually creates the account. What it's asking for us as the arguments is going to be the account contract. This will be the implementation address of the account smart contract. And you are going to see this is the ERC-6551 account. Okay, so let me go back. We are going to be providing that address, right? Because we have to deploy the account. And then with that, I can start generating my token bound accounts. I am going to be providing the chain ID. This will be the ID of the blockchain, the NFT smart contract address, the NFT ID, and the salt. And salt, if we decide not to use a different value for salt, we can leave it as in 0. Okay, so this will be, if we want to be more deterministic as far as the address, I can play with the values in salt. But in this case, I just want to generate them randomly. Okay, so in this case, I am going to just provide 0 here. What that's going to do is now going to generate that code that will be used to build the account. Okay, check this out. What we are doing is we are using this creation code, this interface. Creation code, if you scroll down here, we can see it right here. What that's doing, that is basically generating in memory the byte value that will be then used with the create2 to determine what will be the account value. So this address is generated with the create2. Basically, the create2 builds those addresses. It computes the address value, okay? With the creation code, what we are passing, this will be a proxy contract that allows me to interact. Let me show you. The ERC-1167. So this will be the contract proxy that allows the smart contract to communicate to other contracts as far as the proxy call. So a proxy basically is me making a call on behalf of someone else. Say I send the call to this particular contract, to the account, then the account is going to send the call on my behalf to the destination contract. All right, so let me go back, and then with this information, once I generate this encoded packet, which basically what it's going to do is going to spit all the values, and it's going to grab the attribute to determine what the account address is going to be, which is quote the wallet. Okay, so if we go back, let me go on to create account. We can see right here that once we obtain this by calling this creation code and run through that, then I can determine what the account address is going to be, which is going to invoke create2. Is going to compute the address. We are going to be passing the salt, and like I mentioned, we leave it at 0, so then we are not going to build something that is going to be deterministic. It's just random. And then we are going to be passing the code. Okay, so the code will be the value that we obtained when we did this creation code. Okay, beautiful. Now I have an if statement that if the length it's not 0, then return to me the actual account value, because we want to know. Okay, and then we are effectively going to deploy that account with the create2 deploy function. Okay, good so far? Awesome. All right, now we emit the event. So we have that on the blockchain as an emit event when we execute every single function, every single call to create an account. When we click and create that function, this will be done by the end user. We are going to incorporate this onto the front end. Okay, beautiful. So now check this out. Now that we know when we pass all this information to the smart contract, we know how we get the wallet address now let's work with the account itself, okay? Check this out. Now, with the account, and you can see here that I'm invoking the ERC-6551 from my GitHub repo, okay? Because this will be the implementation interface that we are going to be using. And then the ERC-6551 bytecode, which builds those byte values with the function that we saw previously, the registry, right? So we're going to go back into the registry. When we do this, we are effectively building the byte value that we are going to be passing when we build the account. Okay, so when we build that account, we will be obtaining that through the byte memory. Okay, and you can see that is internal, which means that is something that I'm going to be calling out of another function. This is internal. This is something that we are not going to be communicating with externally. Okay, so this is internal for the smart contract to use with my other functions. Okay, beautiful. So now what I'm going to do, I am going to show you the account itself. Okay, so when we work with the account, this is literally what I want to do with that wallet address. Okay, so I want to allow transferring ERC-20 tokens and transferring the native token using this account smart contract, which every time that I generate a token bound account using this account smart contract, then all those functions that I'm going to be writing and I'm going to be adding into the smart contract are going to be available to be interacting with. Okay, so let's take a look at here. I am going to be providing the following, okay? So if this is an internal execute call, so this, if we want to know more about this one, I believe it's going to be inside the account interface. So this is literally in the account itself, in the base EIP ERC-6551 account contract, okay? There is a function that allows to execute that will basically send native tokens. It's going to allow me to send the native default ERC-20 token. This is not custom. This will be the native token to the blockchain that we are deploying this smart contract, okay? So let me go ahead and I'm going to go real quick because we are going to be deploying this, and then I'm going to be showing you by dropping some test tokens, and we'll do the withdrawal and all that, okay? So check this out. I'm going to code the first function. The first function is going to be send. What am I going to allow to send using this function? It's going to be the native token on the smart contract. So in this case, if I have ETH tokens, if this was deployed on the Ethereum blockchain, I can store the native token, which is ETH, onto the smart contract, and I can then send to other wallet addresses the balance that is inside this smart contract, okay? Which is awesome. But first, what do I need to make sure? Okay, I need to make sure that the owner, and this is not the owner of the smart contract, this is the owner of the NFT token ID. How do I know that? I'm going to show you. The owner function, this owner function, check this out. This owner function, what it's going to do is going to check if the caller matches the owner of the token ID that I'm interacting when I'm using the account. So let's say I build this account, this Tokenbound account, for NFT ID number 150, right? So what I'm going to do, I am going to obtain who is the owner of that token. And if I am the one who's making the call and I'm the owner, I'm matching whatever the ERC-6551 token smart contract gives us back as the value as the owner of that token. If that's the case, I am effectively able to then proceed to transfer the tokens, whatever the tokens are inside the smart contract, okay, or this particular account, okay? So how do we see that? I'm going to show you right here. So I have the message sender owner. Is if I'm the owner of the token of the NFT that is bound to this account, then go ahead and verify what's the balance, okay? What's the balance on this smart contract for native tokens, and then I'm going to execute the to, transfer, and then amount. I'm going to be able to send that to whoever I want. Okay, so if I want to send it to my MetaMask wallet or any other ERC wallet, I can pass that as the value of the address. Okay, and it's payable because we're dealing with the native token. Okay, awesome. Now here's the custom. So when I'm working with the custom ERC-20 token, what did I had to do in order for me to enable this on the token-bound accounts? Let's take a look in here. So what I'm doing is I'm effectively importing the safe ERC-20 and the IERC-20 interfaces. So those interfaces are going to allow me to interact with ERC-20 tokens on the account, okay? So on this particular account, I'm going to be able to do that, which means that I am going to be passing on the function. This function, I wrote it myself. I wrote it and I added it to the smart contract. What I'm going to be doing is I'm going to be passing the destination who is going to receive the transfer of the tokens. I am going to be passing, obviously, the amount. And finally, I am going to be passing the ERC-20 token smart contract that I have as custom. Let's say I have my own ERC-20 token, a custom ERC-20 token, and I airdropped, I deposit tokens onto all my accounts for every single NFT. I have a Tokenbound account. I decided to build a loop. Let's build a loop and start sending those tokens to every single wallet that gets generated, because again, now with this function right here, I'm going to show you back on the registry. With this function, I can predetermine what will be the address, Tokenbound account for each NFT ID, which means that I can call this every single time with a for loop and auto send X amount of tokens in the function, in the call. Okay, awesome. So let me go back. Let me show you. Because I can drop custom ERC-20 tokens onto the smart contract, now I have to be able to determine if the balance inside the contract for the custom token smart contract address that I'm passing as the argument, if there is enough balance in the smart contract so that we can allow the user to withdraw the funds, okay? To remove the funds out of the wallet, out of the ERC-6551 wallet, okay? So we have this, which means that I can now send any ERC-20 tokens onto the 6551 account. Why? Because if I need to withdraw out of the account, I just pass the token address as the argument, and then I should be able to query that token smart contract and determine if I have the balance. If there's tokens on the bound account, I can use those tokens and I can send those tokens out to whoever I decide to send to, okay? Beautiful. Now, NFT info. So this is very important. With this function, I can determine on the Tokenbound account to what token ID is this account attached to. And this is very important. Why? Because with this, I can confirm that ID number 3 belongs to this wallet, or this wallet, this Tokenbound account is attached to token ID number 3. You see where I'm going? Let me go back. If I use this information, I can use this view info to build a front end that could confirm that the NFT ID matches the Tokenbound account, for example. I can confirm those two values are matching. And if I need to do a pre-authorization beforehand, I can use this to validate that the Tokenbound account matches the NFT ID that is attached to, and we are trying to make those calls. Beautiful. So here's the thing. I have the owner, like I mentioned, I'm going to be checking. This is not the owner of the account. This is the owner of the token smart contract. Remember, the account owner is whoever owns the NFT. There's no difference here, okay? Which means if I'm going to be selling the NFT to someone else, all those tokens, all those ERC-20 tokens that 6551 account holds for that NFT are no longer mine, are going to belong to the new owner, which means that once that owner attempts to make the call, they should be able to withdraw the funds. So we have this information here. And all of that is internal to validate that the hash matches, that the owner, that the information, the bytecode that we are interacting with between this particular smart contract and the registry matches and all that. This is internal, okay? Awesome. So let me go ahead and deploy the two smart contracts. We are going to be deploying the NFT collection smart contract, and let's build some accounts, okay? Let's do that. I am going to be compiling the smart contract. So first of all, it doesn't matter which contract do I deploy first. So I'm going to go ahead and deploy first the account. Okay, so we got the account and we're just using the virtual machine with a test machine, not a blockchain. And now we are going to be deploying the registry. Let me find the registry right here. Now we got both the account and the registry. This is the base account. Ladies and gentlemen, again, let me repeat. This is not the Tokenbound account. No, this is the base account, which we will use to tell the registry how is the token going to behave, because that's the account and all those functions are going to be available for each Tokenbound account that we generate using this base account contract. We got the account, all right? Now what I'm going to do, I'm going to take the opportunity to have a test NFT smart contract. So I'm going to do NFT sol. So bring the NFT smart contract right here. I paste it. Let me minimize. It's a normal ERC-6551 smart contract. If you want to know how to build the NFT smart contract, I have many tutorials that I'm working with NFTs, okay? So be sure to check that out, okay? So I'm going to Control S. I effectively compile the smart contract, so I'm going to go ahead now, And this is for the NFT smart contract. I just need to pass the address of the deployer. So this will be my wallet address. I'm going to transact. Now we have the NFT smart contract deployed. Okay, so first thing I'm going to do, I'm going to mint NFTs. So in this case, I have my test contract has a maximum supply of 4 NFTs. So what I'm going to do, I am going to mint all 4 NFTs. Okay, I'm going to say 2. I'm going to pass this address. Okay, I'm going to mint for myself. I'm going to transact, and boom, I got 4 NFTs. How do we confirm this? Let's see balance of, let me pass my address. We got 4 NFTs. Awesome. So now I can pass the token ID and should be my wallet as the token ID of 1, 2, 3, and 4. Awesome. So we got all those 4 tokens on my wallet. I can build the Tokenbound accounts. So let me go ahead on the registry. Before we do that, what do I need to pass? Account contract. This will be the base account smart contract that we deploy with all the functions that we have available. Okay, so we are going to be passing that. Now we are going to be passing the chain ID because this is a test blockchain. This is not even a real blockchain. I'm just going to pass 1. The NFT contract, this will be the NFT smart contract. Let's copy the address, paste it right here. And the NFT ID. Let's build the token account for NFT ID number 1. Salt, make it 0. I'm going to call it. And ladies and gentlemen, this right here will be the ERC-6551 Tokenbound account for NFT ID number 1 in this NFT smart contract. Okay. This is a view call, which means that this is not actually building the interface. This is just the call to determine what the address is going to be, which we can use again to make the front end and display every single wallet address. Awesome. Okay. So let's go back. Now let's go ahead and build it. Now that we know what the address is going to be, let me just go ahead and proceed to build it. I'm going to grab all these values again. I'm going to copy this. I'm going to paste it right here. I'm going to pass chain ID 1, same information. I'm going to pass the NFT smart contract address, paste it here. I'm going to pass the NFT ID, which is 1, and salt, it's 0. I'm going to transact, and boom, we got ourselves our first Tokenbound account. Awesome. Now with this, I want to now interact with this Tokenbound account, which we already deployed. This is where we deploy. So I'm going to show you the return, which we should see the address somewhere here. Here we go. Let me confirm. There you go. This will be the address that was deployed. Okay, so we got our first Tokenbound account. How do I interact with this token address? Copy. I am going to now find my account again. I'm going to check the account, but I'm not going to deploy it. I am going to load with the Tokenbound account, which will allow me to now start using those functions. Okay, now if I paste the Tokenbound account that I just deployed, that I generated, if I deploy that address, now if I go down here, this is, ladies and gentlemen, the actual Tokenbound account. Now I can use functions inside here. Let's see the NFT information. We see that the chain ID is number 1, collection smart contract that we deployed, and the token ID. Let me do the following. I am going to be sending some test ETH to this Tokenbound account. I'm going to copy the address, right? This is just like a wallet. ETH, right? We're going to be sending 1 ETH, and we are going to be sending this to this address. 1 ETH. It's just going to be an empty array. There we go. We passed. And now effectively we have sent 1 ETH from my wallet to the Tokenbound account. Okay. So now we have effectively passed 1 ETH to the Tokenbound account. Beautiful. All right. Now here's the thing. How do I send from the Tokenbound account to another wallet? And let's use this wallet right here, AB, this one. Okay. So what I'm going to do, I'm going to copy the address and I have to return back to my wallet because that's the wallet I'm going to be allowed to send the tokens from. I'm going to go ahead and send. Okay. I'm going to say 2. I'm going to paste the wallet that I want to send that 1 ETH. And I'm going to say 1, but I'm going to be passing 18 zeros because this is in way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Awesome. And finally, I'm going to transact. Boom. We have effectively removed 1 ETH out of the Tokenbound account. Now let's take a look at that wallet that we just transferred that 1 ETH. Okay. There you go, 101. Beautiful. Finally, let's go ahead and deploy a custom ERC-20 token and let's attempt to transfer between wallets. Okay, let me go ahead into here. I'm going to go ahead and deploy a new file. I'm going to say USDT. This will be my fake token. Let's say here USDT Sol. Beautiful. And then now what I'm going to do, I'm going to find that smart contract and I'm going to just paste it right here. And there you go. This is a base ERC-20, a very simple ERC-20 token smart contract. I'm going to Control S. And now let me go ahead and deploy it. And again, it's asking for the owner of the smart contract. This will be, and boom, we got the smart contract. Now let me find, here we go. Awesome. Okay, so what I'm going to do, I am going to be minting to myself, let's say 1,000 tokens. Let's say 1, 2, 3. I'm going to mint 1,000 fake USDT. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I'm going to mint, boom, and we have successfully minted 1,000 USDT fake. Okay, now I am going to be passing my wallet address to confirm that I do have those 1,000 USDT. So I'm going to say balance of, paste, boom, we got 1,000. Awesome. Now I want to send 400 to the Tokenbound account. Okay, so let me go ahead and grab the Tokenbound account, right? And you can see it once again, it's not the account smart contract address, the base account. No, it's going to be every time that we generate a new Tokenbound account, we are going to be interacting with the account ABI using the address of the Tokenbound account. Okay, so now let me go ahead and copy my Tokenbound account, the USDT, the fake USDT. I'm going to now say I'm going to pass it to that Tokenbound account. This will be the address, and I'm going to say I'm going to pass 356 USDT tokens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we're going to pass custom ERC-20 tokens. Transact. Boom, we have successfully passed. Now I want to confirm that bound account has the 356 tokens USDT. So I'm going to just confirm it right here. Boom, we got 356 tokens. Now what I want to do, here's the final test. Now I want to, first of all, I want to confirm that this wallet address has no USDT at all. Okay, so make sure that it's 0. Okay, boom, it's 0. Now what I'm going to do, I am going to head into the ERC-6551 account, and I am going to be transferring to this address the 300 or like 200 tokens, not 300, 200 tokens. Okay, and then we're going to go back and confirm that it was able to transfer the tokens to this wallet address. Okay, let's see. So what I'm going to do, I am going to head under the account, and I'm still as the owner. Perfect. Now I'm going to send custom. I'm going to send to the address, which is the address that we got here, right? The other wallet. I'm going to be passing 200 tokens to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, we're passing 200 tokens. And now we need to pass the ERC-20 token smart contract that we want to transfer those tokens from, right? So this Tokenbound account should have 200 tokens from this ERC-20 token smart contract. Okay, so let me go ahead and find what the value is of this fake USDT, and let's use it here. This will be the fake USDT. Let me transact. Oh, let's take a look and see if we indeed transfer from the Tokenbound account, aka the NFT, to this other wallet, to this wallet right here. Let's do it. Let me press once again. Beautiful. Awesome. Alrighty, let's end it up here. You got all the picture around the ERC-6551 account and the Registry smart contract. We know how we are going to be building those two and how are we going to be interacting on the next and final video. We are going to be building the web front end, and we are going to be connecting this to a testnet, just like the real blockchain, and will generate token accounts as if I was the user. If I just connected my MetaMask wallet, I should be able from the web front end to connect this and interact and send and receive tokens straight onto my NFT. Alrighty? I hope you liked this video, and if you do, give it a thumbs up. Subscribe if you haven't subscribed to. Hey, and we'll see you on the next video. Bye.